An investment counselor calls with a hot stock tip. He believes that if the economy is strong, the investment will result in profit of 60,000. If economy is moderate, investment will result in profit of 10,000. However, if the economy goes into recession, the investment will give a loss of 60,000. You contact an economist who believes there's a 30% probability of economy being strong, 60% moderate, and 10% recession. What's the expected profit from this amount? So expected value, um, we saw one situation where we found expected value where we had a table given, and there we know we multiply the values across and add them up. And we can also do that in StatCrunch. So in these kind of situations where you have profits as well as losses going on, you can still do it on StatCrunch if you know how to enter these values. First, let me show you how you do it without StatCrunch, because with so few values, it's actually shorter to do it without StatCrunch. So let's look at that way first. So you have, let me see. Okay, this formula. Expected value equals winning amount times probability of win minus losing amount times probability of loss. And if you have multiple winning amounts, say you will have two terms here, one for each of the winning amount and its corresponding probability. So we add up the terms where there's a gain, and we subtract the ones where there's a loss. So now let's keep that formula in mind and go back to the problem. So you win, profit is like a win, and loss is a loss. So you get a profit of 60,000. That's the winning amount, 60,000, times probability of win. And this 60,000 profit comes if the economy is strong, and the probability of a strong economy is 30%. So you would multiply this with 0.30 plus, and then there's another profit, so that will be added up because all the profit terms are added up. So that one is 10,000, and then we have to multiply by the probability of that one, and that happens when there's moderate economy, and moderate economy is 60% probability, 60% that will grow at a moderate pace, so 0.6. And then we have a loss. A loss is 60,000, so that'll be subtracted. And the probability of that loss is, if that happens when it's recession, and you have 10% probability of recession, so 0.1. And then you compute what this is. So this will be 18,000 plus 6,000, so 24, and minus 6. So that will be 18,000 total. Now, let's say you just want to do it on StatCrunch no matter what. So let me just show you for this problem, and then you will know what to do for the others. So if you want to do it on StatCrunch, of course, there's no window, so you will have to type in the values yourself. So you would open a StatCrunch window. So let me just use this one, and I had 60,000, and the probability of that was that would be when it's a strong economy, so 30% strong economy. So So I will do 0.3 here for 30%. And then you were getting 10,000 with moderate economy, and moderate economy was 60%, so that's 0.6. And then you were having a loss, so you'll put the loss as negative, so negative 60,000. And the probability of that was 10%, so 0.1. And then you erase that unnecessary thing. Backspace. Okay, so now this is the data, and you would do stats, calculator, custom. Okay, and you see you get the mean to be 18,000, which is what we got for the expected value. So I still think that this one probably takes a little bit less time if you do it without StatCrunch, but it's up to you. You must pick one of the two wagers for an outcome. You win 400 if it comes up heads, and you lose 100 if it comes up tails. So the expected outcome for the first one is, so the same formula, you do winning amount, which is 400, times probability of win. So you win when it comes up heads. So head probability is 1/2. Both head and tail have 1 out of 2 probability. So, and then the losing amount is 100, so minus 100. And you lose when it comes up tails. So that probability is also 1/2. And so that would result in 200, and this would be 50. So 200 minus 50 would be 150. And now for the second one, it's 700 for the win. So 700 for the head. And then you lose 200, so minus 200 for the tail. And that'd be 350 minus 100. So that would be 250 total. And you take the one where you have more expected value. Expected value means that if you play this game, both the games again and again, over and over, then on average, you expect to win 150 per game in the first game. And you, on average, you expect to win 250 per game in the second game. So obviously, no single game is resulting in 150 in the first one or 250 in the second one, because you either win 400 or you either win 700. But the expected value is not the result for one game. It's result if it's the average winning amount if you play the game over and over again.